I want to thank everyone for coming. Here's the session today on Internet Explorer 7 security. We're going to go in depth and look at the work that we've done. I do want to again start by thanking everyone for coming. I know it's almost the end here, and I'm happy to see such a large turnout. Either that means everyone's very excited to see what we have to talk about, or people are very worried about the security, and I'm going to make you very comfortable to hear all the things that I have to say. And so today we're really going to focus on all the pieces of things that we've done and what ways that we're making security better within IE7. The quick review of the agenda. I think it's important to understand where we came from and how we understood the components of IE and what it looks like both as a fundamental piece of software and what the world looks like to us within Microsoft, and how did we think about the problem set before we started to implement some of the solutions. And we'll walk through what those problems were and how we thought about some solutions, and then I'll show you what those solutions look like, how they manifest themselves into features, and we'll end up with a demo that shows off each one of those features. As necessary, we'll also dive in to some of the specifics on how those features work. I think it's important to understand the security problem that we look at within Microsoft. Sometimes I speak to groups and they say, you working on security on Internet Explorer, that must be a very difficult job. And in the past it was. In IE6 it was a very difficult problem for us to suffer from some of the security issues. We looked at some of those solutions and we're very proud of the work that we did in Service Pack 2 for Windows XP. And things got better, so the job was a little easier. And as we started to look at things for IE7, I feel more confidence every time I talk to people and tell them, this is what I do. I work on Windows Internet Explorer security. And so far we've had a good track record, and I'm comfortable standing up here to talk about it. And when you think about Internet Explorer, when we think about Internet Explorer especially, we think in terms of the world as Internet Explorer is the core of the world, and everything connects through that. There's the outside of the world, for which we have no control, the internet. And there are good sites, there are bad sites, there are good people, and there are bad people. And we spend a lot of our time thinking about the outside world. But Internet Explorer is a unique application, unlike others that you'll see on the Windows environment. And we also have to deal with things on the local system. We deal with the user profiles, we deal with the system settings, we deal with external helper applications, and then we deal with other things that interact, like ActiveX controls and JavaScript. And how do we work with those pieces to continually think about security and all of the data transmission? So, looking at all of the components of Internet Explorer is a very difficult bundle of things to think about when you just see them in one lump sum. And so as we looked at Internet Explorer and wanted to figure out where the best places to put our resources, we organized some parameters around it and tried to say this piece and this component belongs to this kind of functionality, and this one is over here with that functionality, and helping us to think about ways to improve the overall experience for our developers internally to build the product, for consumers to use the product, and along that line in the middle, IT professionals such as yourselves to implement the product and deploy it in your network and manage it, as well as developers to build to it and still give them the flexibility they need. So we have the user interface components, the things that you see and interact with and things that render for you. Things on the network layer, how do we interact with the network topology? How do we interact with other sites? How do we handle data flows in and out? And then the final piece is, how do we make it look right to the user? What do we do with all the bits that come in off of that network layer? And sort of how do we go between all the other pieces there? And all of the things that we thought about for Internet Explorer security, we thought about in two ways. And it's a hard thing to talk about, to say that Internet Explorer security could have done 100 things to work on security in the product. There's so much that we think about that can be done. This is not to say that we have so many problems, but it's to say that there are so many things we think we could do better and areas that we want to improve. But there's a limited number of resources. And so when we looked at Internet Explorer and put it into this framework, and thinking about it this way, this is how we prioritized those and how we understood which features we could design that would give the most benefit. The other thing to think about with Internet Explorer security, and maybe the reasons that you're here, are what things have we done to improve the situation, but then there's this other category of what have we changed that may cause different situations and different scenarios in the environment. I don't really want to say break your environment, because we hopefully we have not broken it, but we have created some new scenarios that you'll need to work within the parameters of our new security structure. So to understand the kinds of things we were talking about, I think we now have a common language of what the world looked like to us, this internal and external world, and we also have a sense of those pieces. So now we want to look at the data flows and how pieces move in and out. And I apologize, there's not a lot of animation on these slides, but the information as it moves throughout the application itself. And in order to understand, again, how we thought about ways to improve things. So where we started, URL parsing, one of the most basic components. Someone types in a URL, they send the traffic out, we get it back. What does it look like? What did we do? How did we manipulate it? Well, in Internet Explorer 6, and both 6 XP Gold as well as XP SP2, we had approximately 14 different places within the code where we parse the URLs. That's great if you want to get a lot of places to parse URLs and have performance issues or potential for mistakes. So what we found was there was a lot of capability that we could bring to the table through work in the URL parsing problem. On the next piece, how do we deal with the scenarios where the web talks to itself? We have one site interacting with another. We have pages that have multiple components. Very common scenarios. Internet Explorer 6 had very limited mechanisms for dealing with interactions between multiple site content. We made some improvements in that area for Service Pack 2, but we had a lot of capabilities for improvement. And then the last piece, ActiveX has been a platform that we feel so strongly about, with the potential to let developers do anything and do what they need. As we continue to go forward with the approach of ActiveX solutions and letting you have the power to build unique and custom applications, malware developers looked at that and said, oh, these are great. These are ways that we can attack users and come in and find ways that they'll never stop us. So we thought about, how do we put controls around ActiveX? We need this powerful platform for developers, but we've seen a lot of exposure. Most of the vulnerabilities that we've counted in extensibility have to do with ActiveX controls that were never intended to be exposed to the internet. So how do we address that problem? Well, thinking about those things and using the same model, we said, okay, how do we start to reduce some of that attack surface? And how do we cut down the profile that people can come at? Well, one of the first things, ActiveX opt-in. So we talked a little bit about having the power to build the solutions you want with ActiveX, but the control over the ability to lock down and isolate the ActiveX controls that you don't need and were never meant to be exposed to the internet. So Internet Explorer 7 has this ActiveX opt-in feature, which I'll go into in more detail in a little bit. Thinking about code quality, both the overall code quality for the product and specific pieces. We talked a little bit before about the URL parsing piece. So one area that we improved is the centralized or unified URL parsing. We call the CURL curl processor. So one place within the code now that we process URLs. It's much more performant and much more secure. We know that the inputs are going to be the same outputs regardless of the different components that try to call for it. If it's an image object, if it's a JavaScript object, whatever kind of object needs us to do a URL parsing, it's always going to be the same level of cleanliness. And from a code quality standpoint in the browser overall, I'll talk a little bit later in brief about the security development lifecycle, the SDL. IE7 is one of the first browser products that we built to fully use the SDL. We used the SDL in trying to build the new features into Windows Service Pack, XP Service Pack 2 in that version of IE6. But IE7, from the ground up, we used the SDL. Everything went through this process to make sure it was the higher level code quality. And the last big area that we thought about was defense in depth. How do we protect against attacks across that spectrum that we talked about? We can do everything we want to lock down Internet Explorer. We have the enhanced security configuration. It ships by default on Server 2003 on all Windows servers. So if you try to browse a machine using that configuration, you'll find it's a pretty limited experience. It's very secure, but it's not exactly a user experience. So we had to think about using the browser and using your computers from a consumer standpoint as well as a business information worker standpoint. How can we make the platform powerful enough to let them do what they need, but add layers of defense across the internal and external components that we deal with? And so in thinking about that, we were able to take advantage of some capabilities within Windows Vista, the user account control feature specifically, and create a low rights, low integrity process for IE to run and build another layer of protection there. So now we have an outside world, we have an inside world, and we have this middle ground and this controlled area. That's one of the major innovations that we've made with IE7 on Windows Vista across the board in terms of security. It has the most repercussions for potential areas of workaround scenarios and issues with application compatibility, but it also has proved to us, and we've seen in the number of reports for security vulnerabilities, we've seen that it has provided us the largest amount of ground to cover from security and preventing escalation of privilege attacks against users. So great. We studied all this stuff. We know it. We thought of these great ideas. What do we do? What does that look like? How do we put that into use for our users? Well, first we build a really nice chart. It's really important to have charts to show people. And we think about the world in these layers. Again, when we look at things again with that lens of the outside world coming in. So the first bits of things we talked about were the outside, the fundamental pieces of the outside attack, social attacks. How do bad people try to get information from good users? And how does that then have impact on your networks and in your environments? So the three top features that we talk about here, the address bar protections, the security status bar, I'll go into all these things in just a minute, and the insecure settings are all user-exposed features that have a lot of power that let you manage a better environment. Then we get a little closer in, and we think about things that are in the technology approach, ways that we can script code into it and actually improve what we're doing, and from our internal protection, our internal standpoint. So reducing the attack surface like we talked about before, features like ActiveX opt-in and protected mode. And then the last piece that's in there is the depth mode we'll get into in 1 minute. Important to note the two features that are Vista only is the depth and protected mode that I talked about. In looking at the chart that we just had, the outermost ring where users interact with the browser most often is the address bar, obviously. And so the protections that we've put in around the controls there are ways to improve the visibility for the user and ways to note to the user some issues that they should be aware of. Attacks that we saw that interact again with the URL processing piece that we talked about, attacks that we saw that try to exploit users and convince them of different things had to do with international domain names. The explosion, obviously in this audience, it makes a lot of sense to think of the world and the globalization of the internet. Before, historically in IE6, we really focused on an English-centric domain names and in many ways an English-centric internet. And now we really have gone beyond that. And unlike other browsers in the marketplace that added the IDN feature in, we really thought about it for a while and thought about the controls around using IDN and how do we parse different IDN names and what are some valid scenarios and some invalid scenarios that we would see. We actually got some good feedback during the beta process that helped us improve that even more. So the address bar everywhere feature covers the mere fact that every window now has an address bar that will be disabled by default in the intranet zone. So if you have any internal applications that designers don't want to see the address bar for because it messes with the look or the experience, you don't have to worry about that. But your users will see on any pop-up or any site that they go to, they will see an address bar. If it is a pop-up site, then the address bar will actually be what we call a fake address bar, in that you can't edit the URL in there. You just see, it's a display-only piece. You just see the information that's in there. And we designed that feature to help protect users to understand where that content was coming from. It should also give you guys as administrators some more information about the real data sources there if you're looking at interaction with third parties or if you're looking at internal applications. And getting back to the IDN piece, the way we view IDN, if the machine itself is not set up to view that language, I'm not going to show those characters. I have a small joke that they've told me not to tell, but I'm going to tell it anyway now. So what do you call someone who speaks 2 languages? They're bilingual. And what do you call someone who speaks 3 languages? Trilingual. What do you call someone who speaks just 1 language? American. So the IDN concept had that in mind, that if my machine, as an American, I only speak English, I apologize. And my machine only then will show me character sets using the Latin default English character set. If I try to browse to a site using the Arabic or Cyrillic character sets, I'm going to see the Punycode IDN. I won't see the right character sets. The reason we thought about that was the non-Roman language character sets like Arabic, Cyrillic, Greek, etc. Those are pretty easy to see the differences, but it's very easy to craft a lowercase character or sometimes an uppercase character in a non-English language and make the user believe they're on a site that they're not. And by putting the IDN controls in there, we prevent the user from being exploited. How does that then impact the lower level details of the URL processor? Well, the xn -- code, Punycode header prefix helps us know what to do with that URL and how to process it better, and how to look for different kinds of attacks and different kinds of data structures within the URL. So we both have a user visibility feature, but we've gone back and said, how do we fix some things in the code around that? So we thought for a long time about the solutions that we could put together around IDN. One of the reasons we never had support for IDN in IE6, and we waited till we had IE7 to really do it what we believe is the correct way. Along the lines of the address bar protection features, I think it's not I can ask by a show of hands, how many people get phishing emails in their inbox? It's actually not too many, that's good, but everybody's common and understands the phishing. The threat of phishing has continued to increase exponentially, as we're seeing here, through the past 2 years, and the data continues to show a rise in it. It has taken a little bit of a step down last year. We weren't sure exactly why, but we were looking into understanding that with some of the groups that study that kind of information. And we looked at how can we help users not become victims of that? What are ways that we could build pieces in? Is that a technology solution for this? Or is that a feature solution? Or is that a user education feature? And what we found was it's actually everything. And so we created a whole series of new experiences in the address bar. And so again, in the code, as we're looking at the address, if we see different information, and as we process that up through the rendering layer and into the UI, we show different kinds of experiences. If it's a phishing piece, we'll actually warn on that. If it's a known phishing site, we'll block that site. If it's a good site on the other side, then we show a different experience for that. Try to help users get around the problems of where this information is coming from and whether or not they can trust it and how they can make better trust decisions. So these are ways that we're trying to help your users in an IT environment as well as consumers use the machines better. An example of this from a trust standpoint and the phishing, we saw with one customer that had an exchange of an extranet exchange partner that they didn't use very frequently, that maybe every 6 months. When they went to that site, the users didn't know what that site should look like, and it was very easy for them to be a target of phishing. The data transactions were relatively small, but the size of the dollar transactions were very, very large, and it was subject to attack. Somebody could steal tens of millions of dollars on one transaction, and to this business, it would look like a normal transaction, so their auditors would never have caught it. But something like the phishing filter would help your internal business know another business and what it should look like. Because this feature exists in the cloud, and I'll get to the details of the feature itself in a minute, this is a way to help your users stay protected, browsing on the internet to stay protected, as well as browsing through your business partners. This is also disabled by default in the intranet zone, so as we talk about later exactly how it works, you don't have to worry about your internal applications looking like phishing sites by accident. Extended validation certificates are also part of the solution. I talked a little bit about how we want to have this known good site and a different experience around that. And extended validation is an industry effort to combat that problem. How do we build better solutions for that? And what extended validation does is take today's existing SSL technology and make it better. The problems with existing SSL technology are that it just doesn't tell you anything about the endpoint. It gives you no endpoint identity validation. It tells you that the connection is encrypted, so no one can eavesdrop on our conversation, but it doesn't tell you that the endpoint is exactly who you believe it to be and who you should trust. So in the example I gave of that extranet business partner, an extended validation certificate will let them know that this is the partner they believe it to be. And this is, unlike SSL certificates today, these are non-spoofable. So in a traditional example of SSL, a good example from maybe a year ago in the United States, a bank in the Midwest of the United States had forgotten to get the .net domain for their bank. And someone had gone out, purchased the .net domain, gone to the bank's real website, scraped all of their content, went to a certificate provider, and got a certificate issued in the name of that URL. So you go to the website, it has a padlock, it validates properly because it goes up through the right certificate chain, and it looks correct because it's exactly what the bank site looks like, but when I enter my credentials, it goes someplace else. SSL didn't help them solve that problem. Traditional certificates were unable to. The extended validation certificates are an increase in the process of issuing the certificate. So the difference in this scenario then would have been when that malware company or that identity theft company tried to get the certificate from the certificate provider, they would have been asked to provide credentials that they work for the bank, that they're the right person within the bank to get this, and had to validate that the business entity was the same. They would have been unable to do that and so they never would have received an extended validation certificate. So we are trying to encourage consumer endpoints as well as business partner endpoints to use these certificates. At this point, from an internal standpoint, we see values as well for extended validation certificates for globalized companies, and when you have information exchange that may not be open to the entire company, that may be open to a smaller segment, especially in the areas of finance or human resources, where there's very stringently controlled information or very important information. And we are working on making a white paper as well as some technology tools available that will let you deploy internally extended validation certificates. At this point, the only way to deploy an EV certificate would be to use an external provider, someone like a VeriSign or an Entrust, et cetera. Any of the folks that were on that list of the CAB forum members. Every week or so, we see now more and more companies issuing extended validation certificates. It's an exhaustive process that the authentication provider has to go through, and so it's something that takes them time to complete. How we show that to our users is that green address bar, and I'll again walk through all the examples at the end. How does that work, though? Well, starting in Windows XP, we have the automatic root certificate update mechanism, ARCU for short. And what that allowed us to do, starting in Windows XP, is deal with expiration of certificates and adding new certificates. The Windows XP experience, though, is somewhat limited by design and requires an update to that. Windows Vista can leverage that mechanism and extend on it in that it can update the metadata information and update the store dynamically. The key to extended validation certificates is to update the policy OID information that's in the root certificate that's stored on the local machine. So if you have a Windows XP experience, then we have to find a way to actually get that in there and get that certificate in there. If you have a Windows Vista experience, all you have to do is just trigger the start of that mechanism, and Windows Vista will update it automatically. So if you look at the data exchange around an extended validation transaction, the client types in the address of my bank. I go to the bank, and in a traditional SSL and handshake exchange, it provides me the site certificate as well as the chain. I validate that locally on my machine. Well, an EV certificate would have a policy OID in the server certificate, and it would have a corresponding policy OID in the root certificate. So IE7 actually looks at that policy OID and tries to match it to the certificate authority's root certificate. As I said, with Windows XP, the problem that we ran into is Windows XP by design wants to look at the local store and take the easiest path to validate that. So in VeriSign's example, not to use them specifically, but just as a good example, in VeriSign's example, their certificate is already on my machine. So in a Windows XP machine, by default, the system will try to validate against the root certificate I already have because it hasn't expired. It's still good. Well, the policy OID doesn't exist on my machine yet because I haven't received the new root certificate from VeriSign. There's two solutions. You can push down those new root certificates. There's a URL that we use and we can make available to update an executable that updates the root certificates, and we update that on a monthly basis, and we package all the new or new issues or new certificates into that certificate update. You can deploy that across your network and actually install that executable. Sometimes limiting. Within an enterprise, it works pretty well. But if you're running a consumer website and you're worried about your consumers getting that update, you don't have the ability to push an executable to them, nor does it really make a lot of sense to tell them, hey, go down here and download this executable, then come back. So we thought about that problem and found a way around it. And what you can do is you can trigger an update by telling Windows XP, hey, download this little bit of invisible code or a GIF or whatever you want, and download it from a place that you've never seen before with a chain that you've never gotten before. And companies like VeriSign, Entrust, Thought, all of those have created new root certificates as a process, as part of this process. And so they'll issue you a certificate along this new chain that has never existed before. So you'll set up a server, you can have a single server with just that one GIF on it, and as a page renders, the browser is going to call that GIF, the certificate, IE is going to pull the certificate down, we're going to try and validate that certificate, and that's going to cause this the ARCU mechanism to go out to Microsoft and pull down the specific certificate you need. So you don't need to deploy the executable. You can if you want to. It's a great solution because you know it'll be there. You don't have to wait for users to trigger that experience, but it has its own costs and privileges and benefits. So we offer both solutions there. And again, the second solution is really what we designed for a consumer-facing problem. Windows Vista doesn't have that problem. All you have to do is just tell it, here's the new site, I have the new root, it goes out, it verifies it. An elemental piece of the extended validation process is going out and validating whether the certificate has been revoked. So in Windows Vista, by default, we enable certificate revocation checking. It's not on by default in Windows XP. It doesn't need to be. We encourage users to we encourage businesses and users to do it to be more secure, but and that's why we've done it in Windows Vista. It's not a requirement, again, but it is an important thing to incorporate. If you enable the phishing filter in Windows XP, then you will get the functionality you need to enable that certificate revocation checking, and so that's sufficient. If you want to understand the reasons behind that, it has to do with the network plumbing that's in Windows XP was not sufficient to handle the additional checks required for the revocation checking. So that's why we can't make it backwards compatible to enable by default. It would put too much load on the networking layer. And so in Windows XP, there's a whole new, Windows Vista, sorry, there's a new networking stack. And so we were able to take advantage of that and enable the feature by default. So this is what you're going to see when you look at it. You're going to see two things that are important that we've changed. The color, again, green. We're trying to impart the fact that this is a good site to look at. You should continue to proceed as you would. Don't have any caution about this. And we also thought it's important to show the user a better experience information around what the certificate is. In Windows XP, and XP Service Pack 2 and IE6, the experience around a certificate was extremely technical and non-user friendly. So for this audience, sure, you guys could walk through a certificate and understand what it means. To a user audience or a consumer audience, they didn't quite get it and didn't understand a good certificate from a bad certificate. So we've tried to improve that experience and what it's going to look like. So we take the certificate details, and through the default user experience, we show this security status bar, and we let users click on the upper right-hand corner right by the address bar, and they can see some detailed information in everyday language and common vocabulary. If you need more detailed information, we still have that available by clicking the View Certificates option. You can get the meat details of the certificate itself. And in my demo, we're going to walk through that, and I'll show you the policyoids on that. Within your own companies, implementing extended validation, technically, very easy. You're going to acquire the certificate, you're going to install the certificate, and as we talked about with the certificate update mechanism, if you're going to have to push it out or just let users trigger it. We're also trying to have this campaign around the green bar, as we call it, surprisingly. And we'll offer this little logo that you can put on your websites. If you're running into problems with deployment, we're going to provide a feedback alias so that you can get some support on that. We do have an implementation white paper that we have released that talks about how you deploy it in your environment. It also talks in detail about the process for doing the root certificate update mechanism and exactly why it is that way and how that works. It's not a very long document, but it'll give you all the detailed information that I've covered, I believe. Moving on to the phishing filter, another new feature that we've brought in, looking at the layers of protecting users against social attacks. There's a couple of ways that you protect users in an ongoing scenario. You can make an entirely optimized online experience, or you can put bits of that into the local system and hope that users will update it on a regular basis. We didn't really like either of those answers, so we chose both. So we have two pieces. The phishing filter is a mechanism that lets us warn the user against a potential suspicious site and block the user against a known bad site. Technically, as you load the URL, we're firing off the request off to the website to download that information. The URL parsing handler takes that information, that new unified URL parsing handler, takes the information, strips out the domain name, goes over to a local encrypted DAT file we have that is this on your list. There's a DAT file of approximately 10,000 domain names. It changes on a regular basis. We update that DAT file using the Windows Update automatic update mechanism, so that would also then be pushed through things like WSUS to deploy, so we can manage that. If the domain name is not found on that DAT file, we then come back, take the information about the page, and send a request off to the service. So two pieces of that I think should raise some questions for folks. What is it that we're looking at on the page? We have some client-side heuristics, some code that runs in the browser. It's actually part of IE7 that looks at the page. For hopefully obvious reasons, I can't tell you exactly what it's going to do, but it will look at the page and analyze it for known suspicious behavior. The details of what kinds of things we're looking for, we cannot disclose, because otherwise the malware sites and bad sites will just build a way around it. So we will not disclose the details of it at any point. I can tell you we will update that on a regular basis. And so it is a living mechanism. Much in the same way that we update that DAT file, we can actually update the heuristic logic through an update from Microsoft. And we can push that through to you guys to push out to your users. But we wanted to make sure that that had some robust capabilities that were good from the day we shipped over a year ago on through the end of its life cycle down the road. Once we've analyzed that local page and we've essentially given it a score, you can think of the score between 1 and 10 and looking at those characteristics. If that site and that page scores around a 5, maybe 4, 5, or 6, we think that is something we should look at here. I don't know that it's a bad site, but I also don't know that it's a good site. And so we take the URL, we pull out all of the personally identifiable information, so any of your username strings, any of your arguments, any of that stuff is stripped out and sent over an encrypted link to https://urs.microsoft.com. That's a service that we run. It runs on our network. It's cluster aware, it's global, it's high volume, and it takes those requests along, so it takes the page you were looking at without any of your PII, and it takes the score of the heuristic analysis from your machine and sends it off. The first thing we do in that service is say, do I know about this URL? Have I seen this one before and I know that it's bad? And if that's the case, we send back a code to the browser, down the path, telling the browser, this is a bad site, block the user. If we haven't seen the URL before, we take that URL and the score and we put it in a bucket. We don't record where you came from. We don't record anything about you because the client side is no longer important. It's only now important for us to look at that site and understand why our mechanisms thought that site might be bad. If you have 10,000 users that hit that same site at the same time, we'll get 10,000 reports, but we'll never know that it's your users. We don't care about that. We don't want to store it. We've actually had other third parties come in and check our systems to make sure that not only do we not record the information, but any information we have is not available to other business units within Microsoft. We protect the privacy and confidentiality of that information. We only use it to analyze the sites and improve our service. Once we have those pieces, right here, once we have those pieces together, we create a report on it, and we have human graders that actually look at those sites. So if those 10,000 reports came in, that would move up our escalation of priority, and we would say, 10,000 reports in a short period of time, this looks like something that might be affecting users right now, and we should be aware of it and work to block it if it's a known site, or just let it pass through. So we have some human graders that sit there. They will actually go to the website, look at it. They have a bunch of tools at their disposal to scan for malware, to scan for back-end servers in countries known to host identity theft, et cetera. And they look at the entire ecosystem behind that site as much as they can. If they have questions, they'll contact the site owner. If not, they'll go ahead and put their score and their evaluation into our system, into the database. Users can report as well. So if the automated system and the heuristics don't catch the site, like you come to a site that you get an email and you click through, and you know this is a suspicious, or no, this is really a bad site, you as a user have the option to submit that. So your users can submit these things. If you're the site owner, if you find out that customers are contacting you saying, I come to your website sometimes and you have implemented something unbeknownst to you, you've implemented something that looks suspicious or looks to be a known problem for some reason to our service, you have the ability to go in and report. The difference between those two reports is when a user submits something, it just goes into our queue and adds to the pile associated with that URL. When you as a site owner go in, it goes to the top of our list, because we don't want site owners to be suffering if there's a mistake. If you're a site owner and you know it's a bad site and you're trying to get off our list anyway, the human graders will prevent that from happening. So that's the ways we've built in human mechanisms in addition to the technology mechanisms to improve the service and make it a better experience and more robust across the board. We don't just rely on sites that we know about. We don't just rely on things that users or site owners have submitted. We work with approximately 30 different services around the world in different countries to help us get a globalized view of the phishing problem. And they help populate our database. So we have a holistic view of phishing from the consumer endpoint, the business user standpoint, the site owner standpoint, as well as a globalized crawling of the web view. How well do we do? We think we do pretty darn well. Last time I checked, it was about 900,000 a week we were up to. And so we are continuing to block the negative experience of the internet for more and more users. We really encourage companies to deploy this feature. It is something you can control by group policy. It's not on or off by default when you install. It's important to know that. As part of the default experience, the user has to make a choice. They have to decide, do I want it or I don't? We don't pick a solution there. We encourage users and we encourage companies to deploy it. We encourage companies to enable it for their users. One of the pieces of feedback we've gotten a bunch in questions is, can I deploy the phishing filter service in my company? I don't want, you believe me when I say that the security and the privacy of the information is there. Microsoft is not going to hold any of that. And you do believe me, I'm sure. But companies don't want to send that information. Unfortunately, at this point, there's no way for us to provide a service like WSUS or similar where we can push the infrastructure to you with the phishing filter. We don't have a mechanism that lets you do that. We are looking at ways that we might be able to do that to help you avoid data transiting your network or just additional overhead on the network. The top two concerns that we've heard around the phishing filter service. Again, looking at users and security and how they use their machines and ways that they need to interact with data and need to use their environment. One of the things that we found, we had a report, one of our colleagues' brother works for a company that's a very small company, deals with another very small company who makes a very specialized piece of software to do a specific report, all web-based. When the brother went to this website, he couldn't run the ActiveX control because it hadn't been signed. So Authenticode, one of our IE6 security mechanisms, blocked that from working. So the workaround that he was told is, go ahead and set your security settings to low. Well, he had to do his job, so he did it. Set his machine on that, kept doing his job, finished the report, turned it into his boss, had a great weekend. Comes back on Monday, gets some joke mails from his friends, he gets some phishing emails, starts to browse the web. That afternoon, his machine's not working so well. Doesn't remember, well, why is my machine not working? He calls the help desk, they come. A little while later, he's been browsing, he was infected with malware. And his machine set to low. He had forgotten he had set it. So we thought about that and said, is there something we can do to help protect users from just forgetting what they've done? And so we've denoted many of the settings, the critical settings within IE, and IE7 specifically. If they are going to set the machine in an insecure state, as soon as the user sets those, we flag it red, and we also have an information bar that comes across the top. To help fight against the scenario I talked about with our colleague's brother, when over the weekend, if you shut down or close IE and then restart, the experience you'll see is a page notifying you you're at risk. So we really want to be in your user's face about the fact that their machines are insecure. So your environment may not allow users to change certain settings, may allow some settings to other settings to change. I would hope most businesses don't allow their users to just change their internet zone settings to low, but that could happen. And if it does, here's a feature that we've put in place to help protect your users that may have made this mistake and forgotten about it. All they have to do to get back to a secure state is click the Fix My Settings or Fix Settings for Me. It'll actually go in and revert back to all the secure defaults that we ship with IE7. Earlier I talked about how we designed Internet Explorer from the ground up with the SDL, the Secure Development Lifecycle. It's a relatively complex chart to look at, but it effectively means as we develop something, we review it again, we review it again. And we just constantly continue to improve on the code quality. And we throw different types of attacks at it. We use fuzzers. We use different kinds of logic. We really do everything we can to improve the code base itself. So integrating the SDL process helped us ensure that we have a very solid code base, and I would say the most solid code base ever for IE7. It's important to know that the IE7 code base for Windows XP, for Windows Vista, and Windows Server 2003, the same code base. So you'll see the same features, you'll see the same interactions and implementations. The differences in terms of end user features or functionality, the protected mode is available on Windows Vista, which is not available on Windows XP, again because of the user account control feature. But otherwise they're the same code base. And so we feel that the security of the browser is strong enough to deploy on Windows XP if your organization's not ready to go to Windows Vista, and we have additional features and benefits that you can get from going to Windows Vista. Looking back at ways to protect the user against those threats that ActiveX presented where controls were never meant to be exposed to the internet, what we actually do in the scenario of an XP machine, at the install time, we go ahead and create a new key that in the registry that is the approved control list. And so we look at all of the controls on the machine that the user has previously used, And we take all those controls and we put them on the approved list. We take everything that is a core part of the Windows or IE experience, the core element ActiveX controls that we need, we put those on the approved control list. We also have a process that we've initiated with many of the large control vendors and third-party extensibility vendors like Adobe and Apple with QuickTime, RealPlayer, et cetera. And we know that their controls have gone through a security review process. So we put those on the approved list. Everything else stays where it was and is therefore disabled by default. If you're on a Windows Vista machine, obviously we're not going to carry forward any of those scenarios from IE6 because there is no previous state. So we're just going to have this very small set of controls that are enabled by default. The goal there was to protect against the so-called drive-by downloads, where I get convinced to go to a website. All I do is go to that website, a control gets instantiated, something gets exploited, and malware is put on my machine. ActiveX opt-in is our solution for that problem. So fundamentally, under the covers, we have a list that you can manage and maintain for approved controls. And anytime a control is we try to instantiate a control, we look for the GUID and the keys. And if it doesn't match up, we display an information bar to the user saying this site wants to invoke this control. Do you have to approve it? And we force the user to approve it. Now, we thought about some of those things and said, users are really smart. They're going to see that warning, and they're never going to click that. Users know they never want to just do something without thinking about it because they understand the implications of security and they understand everything. Well, then we came back to the real world and said, okay, maybe not. They're going to click because they want their media player to work, or they want their free music, or they want their whatever they're going to get, they want it to work. So they're going to click. So within Windows Vista, we are able to use protected mode as the next logical extension of that, and how we can control the experience for the user and help guard against their making what we call poor trust decisions. So they go ahead and they enable that control that they shouldn't have. Well, we talked a little bit at the very beginning about Internet Explorer running in this middle ground area as a restricted process with low rights. And in that function, Internet Explorer doesn't have the permission to write to critical system areas. So the user could have made a bad decision. The ActiveX control tries to download a file to a protected area like the system registry. Can't do it. So we use protected mode as a layer of defense. I have a detailed slide in just a minute to cover back onto that. Another area within both XP as well as Vista that you can go to increase security is the data execution prevention, and DEP. We would love to enable this by default. It doesn't let it controls the way in which applications can read and write to the stack, and doesn't let the wrong types of data put their information into the executable stack. And so therefore it prevents incorrect actions and incorrect activity from the user standpoint. It prevents the machine from being corrupt, essentially, because the execution stack is where the real vulnerability would lie. We looked at enabling DEP, and what we found were certain controls that were very, very common that users would use weren't DEP aware. And I don't want to say they were poorly written, but they wrote to the execution stack, and so therefore, if we enabled DEP, then it broke that experience for users. We are working very closely with those vendors to improve their code to make it DEP aware so that you can enable DEP and really increase the security. I don't know if I could emphasize it even more, that you will really increase the security of your experience by enabling DEP for your users. We have a documentation about increasing the default security configuration, especially geared at IT professionals. And one of the recommendations in the document that we suggest several times is DEP. We have a bunch of other recommendations in there, and I'll point you at that documentation at the end as to ways that you can take the default security configuration and some suggestions for your users. Some are very easy to implement through group policy, and others require a little bit more sophistication in your approach. But if you're going to implement DEP, first you need to go ahead and test it on your standard base machine, make sure everything works with it. Contact vendors if you're noticing some add-on extensibility is not working. Contact the vendors, make sure they have a patch available or a new version, and when they do, deploy it, and you should see a much better scenario in your environment. So now we're going to look at a little bit of a model as to how Internet Explorer looked for IE6. So you had your standard process on one side, and all your data and all your other files there. Running with full administrator privileges, you could write to anything you needed to. If you had cache content writing to the temporary internet files, go right ahead. You had permission. If you wanted to go ahead and change any of the user settings, both within the internet control panels or underlying settings for other applications, sure, go right ahead. You could do that. The other thing we needed to do was install controls. Installing controls required administrative access. It still does. We have some solutions around that in Vista that I can talk about. But this is the way that Internet Explorer worked in IE6 to write to the system. You had full access, you could do it. If you've ever tried to run IE as a standard user, some problems come in. And so this is an illustration of what you're seeing. The problem? That malware can use that path and come right in as administrator and install and run and do whatever it needs to do. You can also do that through the user piece and the user settings. Now, Windows Vista has protected mode. So we've redesigned the architecture a little bit. We actually have two separate processes running. We have a standard user, low rights, low integrity process that runs to let me browse the internet. That's what I normally use. Lets me do what I need to do. If I want to do anything that requires writing to certain areas or elevation, we actually have a process that comes in, a broker process that interacts with the operating system at a high integrity bit and lets me do what I need to do. You cannot script the broker process. You can script a call to it, so you could force that dialog box up, the Save As dialog box, but the Save As dialog box is running in a higher user process, and you cannot script activity to the Save As dialog. You can't get around it. And so we feel that protected mode really will help escalation of privilege and elevation of privilege kind of attacks, where the user is convinced to do something bad, and then the system is abused through that scenario. So walking through exactly what you can and can't do and how it's going to work. By default, the low integrity mode of IE has the ability to write to the TIFF. We know we need to. So the TIFF itself is a folder with low integrity, because not only applications within Vista, but folders also have layers of permission around them. And so the low integrity IE process can write to a low rights folder, like the TIFF. Talked about the broker process. So when I kick off something, the Save As dialog box, for example, or the change settings control panels, anytime I kick those off, you'll actually, if you look at Process Explorer, you'll actually see two separate processes run there, and IE user is the one that comes up with the same privilege token as the user you're running under. So if I'm running as a standard user, I'll escalate from low to standard. And then if I need to do something that requires administrative privilege, I have to escalate again. I have to provide more credentials. But if I'm running as administrator, I go from, again, a low into a standard mode when that Save As dialog box comes up and lets me do things. And that's our way to let users do what they need to do, and does, again, require user interaction. You cannot script it. I actually have to click into that interface. Then there's another process for how we deal with installing ActiveX controls. The IE install process. And when that gets launched, when you need to install a control, that's going to then kick off the query as to whether or not you have the right credentials to install. If you're not an administrator, you're going to see a UAC prompt, because I'm sure you all have UAC enabled. That's the only way you can get protected mode. If you turn off UAC, protected mode goes away. And so you have this the UAC prompt that comes up to install a control. There is a solution for businesses called ActiveX Installation Service. It's a service that runs both on the client as well as the server that lets you get around the need for administrative privileges to install controls. So again, we're adding layers of security to IE here, but we realize it has to be deployed and maintained in business environments. And so how do we figure out solutions around that without compromising some of the great work that we've done? And the ActiveX installation service is our answer there. It lets you publish a list of ActiveX controls by GUID that the user can install without needing additional permission. So the installation service contacts the installation process contacts the installation service, which then queries based on the GUID and says, do I have permission to install this GUID? If it comes back and says yes, you don't get credentials, you just install, you move on. If you need credentials, because it's not on the list, you'll see the UAC prompt. All this is great, except in the case of applications that aren't protected mode aware. So if you had an application that tries to write to a restricted area of the system and then read from that, when you run with full privileges, everything works great. You can write, you can read, no problem. You can come back 2 sessions later and still read it. With protected mode, we have a problem. And we created that problem, again, by intent. But how do we get around that? Because we realize that not every application is protected mode aware. And we also realize there are some scenarios where your application doesn't necessarily need to be protected mode aware. So to accommodate for that, we have essentially a redirector that sits in IE and says, I'm going to take this write, and rather than write it to a restricted area, I'm going to put that down here in a volatile area that I have low integrity permission to write to. So your performance will still be successful if you're trying to write a file to the system, but it's not going to write it to a restricted area. It's going to write it to a virtualized directory, which will actually be under the TIFF. And so the user has the safety and security of knowing this is a volatile area that could get erased. Perhaps you have a group policy setting that deletes your TIFF every time you exit or on a specific periodic basis. That's one of the good things you want to do is you want to delete your files on a regular basis so that you don't have any security compromise or cookie sharing or violations, etc. But we also then have created a scenario where your application using protected mode has written to a file to the system, known that it was a successful write, but you can't read it later. That problem still exists for the long term. So if you have multi-session experience, protected mode will cause some problems. And we have some suggested workarounds on the IE team blog. We've posted a bunch of material on how to write your applications to be protected mode aware. If you're within the same session, though, the compatibility redirector, that shim, will take the write, put it into the TIFF, report back the proper status to your application. Your application will continue. If you need to read, we maintain the state of where we put that file, and so we can read it up again for you, and we can bring it back to you. So within session, protected mode is going to give you all of the security values, and won't break anything. It's when you cross sessions and have different processes running, that's when you're going to run into problems with protected mode. Same kind of scenario as I say with different processes running. If I have 3 different instances of IE running on my machine, the protected mode redirector shim information is not shared across those. It's one of the changes that we've made to the overall security model of IE is that we share information and common information across tabs within the tab browsing experience, but we don't share information across processes. And so one of the reasons we did that, we prevent the cross-domain sharing violations. And if I had a window open and I have the user click on a link to force a new window open, as the parent, I would be able to tell that child window to go here or do this, or I could sniff on content in that. So the reason that we've instituted the separation of processes and the comm abilities across those windows is to prevent that attack. So if I click on a link that opens some malware company sends me an email, I click on that link and I open that window, they try to call across comm to get to that other window. The answer comes back and says, I don't know what you're talking about. That window doesn't exist. It's a non-callable object. So we've really tried to put another layer of security in there. Jump over here and do my machine. There we go. Hey. The first thing that we talked about earlier was the address bar protection. So I'm going to show that really quick here. We have a bank site that we've set up. A very common experience. I click on the account login button, and it brings a pop-up window asking for credentials. You'll notice again, the address bar is here at the top. A little hard to demonstrate in a large environment, but you'll see the history there is blank because this is that fake address bar I was talking about. If I select it and try and type, you'll see I can't actually do anything. This is a non-navigable window. So we've protected the user by giving them information as to what they're looking at, but we don't much like a normal pop-up window, don't make it a full process installation. We talked about IDN support. So an example of how this works, the very commonly associated Secunia IDN vulnerability. What it's going to try to do here is actually open an IDN link that in other browsers would show the puny code, so the xn Secuni 8 nff8nf.com, but the user would actually see secunia.com in their browser window. So when I go ahead and click on that link, it's going to open this up for me. As long as I have an internet connection, there we go. The page doesn't come up because of they brought their site down. But what you'll notice, two things. I see the puny code. I don't see the English character set. And you'll see a little icon here that denotes that this is an international domain name. Very user-readable information here. It tells me that my machine is currently using Cyrillic and Latin. And what it tried to show is Secunia itself, but what it's actually showing is the encoded address. Because I don't have the right kind of language set installed, this is the experience I'm going to see. It prevents users from being exploited. And then the last piece is, if I want to actually go ahead and add a language, and let's see if it'll. Oops. Close my window there. If I've successfully added the right language, which I have not, unfortunately. So if it would display the correct language. I just picked the wrong language by. Let's move on here. We talked a little bit about the security status bar, and so I want to show some examples of this. This will be the phishing filter. The first example is a suspicious site. Having a little bit of performance. So a bogus email that we get comes in. Clearly Hotmail's filters would have actually caught this, so I had to capture this for my demo example. This would never happen in a real Hotmail account. But I come to this page and looks at the page and says, this is suspicious. So what you noticed, because we have some network delay here, it's a good experience. It loads my page, and at the same time, it's going off and querying the service like we talked about. And the service comes back and says, it is a phishing site, it's a suspicious site. I don't know what to do with it yet, so I'm going to record that and I'll do the manual processing around it, but it's going to show this and trigger this experience for the user. We pop this down in front of folks so that they can see it. It gets in front of them so that they don't just see this address bar, which is a cross between yellow and maize. And we want to be as blatant as we can about things. Now, to show the experience of a known phishing site, it launches the page. It should load that page up, and then it navigates me away. So IE7 actually received a command from the phishing filter service. It received a response code saying this is a known site. And what we do is we navigate the user away. And you'll notice that we don't have a forward or back, so we're not actually navigating to a real page. We're creating this interface page. And so the user can't get around it without selecting one of the two options. Our default and preferable solution is to close the web page, but we do let the user continue through. You will notice if we let the user continue through, they still have the red address bar and the known phishing website. If you click on that report, you'll see what it is. We talked a little bit about the process of reporting, so here I'll go in and show you what that looks like. Guess the network is ready for the conference to be over here. It's moving a little slow. Let me jump over to something else and I'll come back. Hopefully that'll load up properly. Let's look at the extended validation certificates. We talked a little bit about that. You can see a site that I haven't gone to yet. Go to one that I have gone to. We're not having much luck here with the network. Try one more. So now I'm just doing the normal stack of actually querying the page. Here we go. So it's pulled down the page, and the exchange over the extended validation certificate has happened that I've pulled down the certificate. Technically, no different than the experience you would have with a standard SSL certificate. Here's a difference in the badge information. We're going to tell not only who has issued it. Oops, that page finally came up. We'll come back to that. But also the name of the company and the location. If you want to get the more detailed information, this is what you're used to seeing with IE6. We found that most users didn't understand what it meant, didn't know how to trust it. If we look at the details, and this policy identifier, I believe, is the policy OID that is assigned. Oops, get it all there. That is the policy OID that is assigned by VeriSign. That's the policy OID they've selected as verifying extended validation in their environment. So it'll be different for every provider. You can create your own once we bring those tools to you, that you'll be able to create your own policy OIDs. There's no specification around there. But it'll have to match between the server certificate that's issued and presented to the client, as well as a map up back into the root. So you have to have that chain there. And here we can see the chain. What VeriSign has actually chosen to do is create an intermediate certificate authority that is the way in which they're going to match the extended validation. So we talked about the Windows Update mechanism and how it has to be a little different. And what they have chosen to do is create this whole new infrastructure and certificate mapping. And so this is the way in which they're helping customers solve that automatic update chain for Windows XP. So your certificate authority will help you with that process. You don't need to build an entire chain around it unless you're doing something internal. Jump back over to that phishing filter one. So here's what you're going to see on a report. You're going to see the site URL. We do support all 37 different languages that we have graders that speak, so the sites can be in different languages. And then you can vote whether or not it is if you're the owner or not of the site. Depending upon the experience, you get different questions. Here it should bring up, as soon as it can, an owner form that's going to have a lot of detailed information that you'll have to provide for our graders. Because remember, again, our graders are human beings that are going through this, so the more information you give them, the better. And then the contact information will obviously be essential if you ever find yourselves needing to submit a request here. Jump over and show you the ActiveX opt-in feature. So here's an example. I'm using my browser. I've gone to a website that is trying to instantiate a control, a fictitious control we've created. It's not on that pre-approved list that I've talked about because I've never used it before. So by this site, unbeknownst to me, this site's going to try to install malware. We expect the traditional user experience, if they're not thinking too much about it or they really want it, they're going to go ahead and click to run that control. We're going to come up and have an authenticate dialog box that says, are you sure you want to do that? They're going to do it anyway. Site loads its page. OK, I'm going to click here and get started. Well, that doesn't look like it did too much. Well, what we've actually seen now is ActiveX opt-in protecting me from that drive-by scenario. But unbeknownst to me, what it was trying to do was actually write to my startup file as soon as I clicked on that. So here I have a spyware file that's now in my what appears to be startup folder. But if I click on that, you can actually see that it's under the virtualized directory, under my temporary files. So if I go to, I clicked on the wrong one. If I click on virtualized, it'll show me the directory. What it was actually trying to write to is C, users, IT forum, app data, roaming, Microsoft Start menu, and my startup folder. So that's where it is. If I go over to my real startup folder, let me try and have them both at the same time. You can see my real folder is empty. And that one, it's hard to see the full path. But protected mode stopped it from writing to my real folder. One of the problems with this demo is I'm showing you nothing actually happening here. So it didn't write to the real startup folder. I go to restart my machine. I'm not going to be infected. Well, these guys are really persistent. They really want to get their spyware on the machine. So go ahead and click here. It's going to try and download a file, and I'll show the last bit of defense in depth. It's going to tell me, do I really want to run that machine, that file? More authenticate dialog boxes. And here's defense in depth with Windows Defender actually scanning the download and telling me that it's not something that I should be running. Jump back. I'm actually over time here. The last piece, some changes that we made in HTTPS for Windows Vista. We disabled SSL version 2 by default. So if you have any websites that are running that, you'll need to change. I don't have any questions. Time for Q&A now. I'll take those separate. I'll be around. Related content, all the stuff that we talked about, and links to our different sites. The deployment guide, as I mentioned, is up there. And the most important, I think, is the team blog. That's where we publish information, security-related, developer-related, et cetera, et cetera. And the last of the resources, complete the evaluation for the chance to win an HTC Touch smartphone. The deck is available on the the event website as well. Thank you very much.